This is SpaceTime, Series 24, Episode 113. Coming up on SpaceTime, the cosmic impact that destroyed an ancient city. NASA's TESS finds its smallest exoplanet yet. And the launch of Landsat 9 on NASA's new mission to monitor the Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study argues that the ancient Bronze Age Jordan Valley city of el-Hammam was destroyed by an asteroid impact. In the same way that the biblical story of Noah's flood could have originated in accounts of the ancient Mediterranean Sea's inundation of the Black Sea, was this the basis for the biblical story of Sodom and Gomorrah? In the Middle Bronze Age, about 3,650 years ago, the ancient world city of el-Hammam was a busy, growing commercial hub. Located on high ground in the southern Jordan Valley, northeast of the Dead Sea, the settlement in its time had become the largest continually occupied Bronze Age city in the southern Levant, with a history going back thousands of years. At that time, el-Hammam was 10 times larger than the capital of the Jews, Jerusalem, and 5 times larger than Jericho. The study's lead author, James Kennett from the University of California, Santa Barbara, says this was an incredibly culturally important region, an area where much of the early cultural complexities of humans developed. el-Hammam has become a favourite site for archaeologists and biblical scholars. The mound hosts evidence of culture all the way back to the Copper Age, all compacted into layers as the highly strategic settlement was built, destroyed and rebuilt over millennia. However, there's this 1.5 metre interval in the middle of the Bronze Age stratum that caught the interest of researchers because of its highly unusual materials. In addition to the usual debris you'd expect from destruction through warfare and earthquakes, scientists found pottery shards with outer surfaces melted into glass, bubbled mud brick, and partially melted building material. These were all indications of an anomalously high temperature event greater than 2,000 degrees Celsius, and much hotter than anything the technology of that time could produce. At the time, Kennett and his research group were building the case for an ancient cosmic airburst about 12,800 years ago, which could have triggered major widespread burning, climatic changes and animal extinctions. But seeing these charred and melted materials at el-Hammam triggered their interest. Kennett says there's evidence of a large cosmic airburst close to el-Hammam of an explosion similar to the Tunguska event in 1908. Tunguska was a roughly 12 megaton airburst of a 60-metre wide meteor over eastern Siberia. The blast was enough to flatten trees into matchsticks over an area of over 2,000 square kilometres, and the flash was bright enough to be seen a third of the way around the world in London. And Kennett was seeing evidence of what looked like similar levels of devastation at el-Hammam. The findings, reported in the journal Nature Scientific Reports, showed that the shock of the explosion over el-Hammam was enough to level the city, flattening the palace and surrounding walls and mud brick structures. The distribution of human bones indicated extreme disarticulation and skeletal fragmentation in nearby people. Kennett found further evidence of an airburst event by conducting detailed soil and sediment analyses of crucial layers, which turned up tiny iron and silica-rich sphericals and melted metals, both telltale signs of asteroid impact. Just as importantly were findings of shot quartz, sand grains containing cracks that form only under extreme high pressure. This is another clear signpost of an asteroid or comet impact. The authors say the airburst could also explain the unusually high concentrations of salt found in the destruction layer, an average of 4% in the sediment and as high as 25% in some samples. It's thought the salt was thrown up due to high impact pressures of the meteor as it likely fragmented upon contact with Earth's atmosphere. It may be that the impact partially hit the Dead Sea, which is rich in salt, and the local shores of the Dead Sea are also rich in salt, so the impact may have redistributed those salt crystals far and wide, not just at Tal el-Hammam, but also nearby Tal es-Sultan, which has long been proposed as the possible biblical Jericho, which also underwent violent destruction at around the same time. And a third city, Tal Minrin, was also destroyed around this time. The author suggests that this high salinity soil could have been responsible for the so-called Late Bronze Age gap, during which time cities along the lower Jordan Valley were abandoned, dropping the population levels from tens of thousands down to just a few hundred nomads. Nothing could grow in these formerly fertile grounds, forcing people to leave the area for centuries. Evidence for the resettlement of Tal el-Hammam and nearby communities doesn't appear again until the Iron Age, roughly 600 years after the city's sudden devastation in the Bronze Age. Of course, Tal el-Hammam has long been the focus of an ongoing debate as to whether it could be the biblical city of Sodom, one of the two cities in the Old Testament book of Genesis that were destroyed by God for how wicked their inhabitants had become. According to the Jewish Bible story, only Lot and his family were saved by two angels who instructed them not to look back as they flee. However, Lot's wife couldn't resist. She looked back and was turned into a pillar of salt. Meanwhile, fire and brimstone fell from the sky. Multiple cities were destroyed. Thick smoke rose from the fires. City inhabitants were killed and area crops destroyed in what sounds like an eyewitness account of a cosmic impact event. True or not, it's a satisfying connection. Kennett says that all the observations stated in Genesis are consistent in a cosmic airburst, but there's no scientific proof that this destroyed city is indeed Sodom out of the Old Testament. Still, researchers say the disaster could nevertheless have generated an oral tradition that may have served as the inspiration for the written account of the book of Genesis, as well as the biblical account of the burning of Jericho in the Old Testament book of Joshua. This is SpaceTime. Still to come, NASA's TESS finds its smallest exoplanet yet, and the launch of Landsat 9, NASA's new mission to monitor the Earth. All that and more still to come on SpaceTime. NASA's TESS, Transiting Exoplanet Survey Satellite, has discovered its smallest world so far, an exoplanet between the sizes of Mars and Earth. The planet, called L98-59b, orbits a nearby red dwarf star just 35 light-years away in the southern constellation of Volans. The findings, reported in the Astronomical Journal, show two other worlds are also orbiting in the same system. L98-59b is around 80% the size of the Earth, and around 10% smaller than the previous record holder discovered by TESS. As for its host star, L98-59, it is about a third the mass of the Sun. As for the two other worlds in the system, L98-59c and L98-59d, they're around 1.4 and 1.6 times the Earth's size respectively. L98-59b, the innermost world, orbits its host star every 2.25 days. Staying so close to the star, it receives as much as 22 times the amount of energy the Earth receives from the Sun. The middle planet, L98-59c, orbits every 3.7 days and experiences around 11 times more energy than the Earth. And the most distant of the three worlds, L98-59d, orbits every 7.5 days and is blasted with around 4 times the radiant energy that the Earth receives. So all of these planets are too close to the host star to be in the star's habitable zone, the region out from the star where temperatures would allow liquid water, essential for life as we know it, to exist on the planet's surface. However, all of them occupy what scientists are calling the Venus zone, a range of stellar distances where a planet with an initial Earth-like atmosphere could experience a runaway greenhouse effect that transforms it into a Venus-like atmosphere. Based on its size, the third planet could be either a Venus-like rocky world or more like Neptune, a small rocky core cocooned beneath a deep atmosphere. While all three planet sizes are now known, further study will be needed to determine if they have atmospheres, and if so, what gases are present. The L98-59 worlds nearly double the number of small exoplanets, that is, planets beyond our solar system that have the best potential for this kind of follow-up. The study's lead author, Veselin Kostov from the Search for Extraterrestrial Intelligence SETI Institute and NASA's Goddard Space Flight Center in Greenbelt, Maryland, says for atmospheric studies of small planets, you need short orbits around bright stars. But such planets are difficult to detect, and so this system has the potential for some fascinating future studies. While L98-59b is a record for TESS, smaller exoplanets have been discovered in data collected by NASA's Kepler planet hunting satellite, including Kepler 37b, which is only 20% larger than the Earth's moon. All three of these newly discovered planets were found by TESS using transits, that is, a periodic dip in a star's brightness caused as a planet passes in front of it as seen from Earth. This report from NASA TV.
TESS, the Transiting Exoplanet Survey Satellite, is NASA's newest exoplanet mission. Led by MIT, TESS will find thousands of new planets orbiting nearby stars. During its 2-year survey, TESS will watch a wide variety of stars, looking for signs of planets ranging from Earth-size to larger than Jupiter. Each of TESS's cameras has a 16.8 megapixel sensor covering a square 24 degrees wide, large enough to contain an entire constellation. TESS has 4 of these cameras arranged to view a long strip of the sky called an observation sector. TESS will watch each observation sector for about 27 days before rotating to the next. It will cover the southern sky in its first year, and then begin scanning the north. TESS will study 85% of the sky, an area 350 times greater than what NASA's Kepler mission first observed, making TESS the first exoplanet mission to survey nearly the entire sky. Because TESS's observation sectors overlap, it will have an area near the pole under constant observation. This region is easily monitored by the James Webb Space Telescope, which allows the 2 missions to work together to first find and then carefully study exoplanets, expanding our understanding of worlds beyond our own.
This is SpaceTime. Still to come, the launch of Landsat 9, NASA's new mission to monitor the Earth. And later in the science report, paleontologists discover the earliest known ankylosaur. Think of it as being a sort of dinosaur tank. All that and more still to come on SpaceTime. NASA has successfully launched the latest Landsat 9 environmental Earth observation satellite. The spacecraft is designed to monitor changes on Earth's surface. The joint mission by NASA and the United States Geological Survey lifted off aboard a United Launch Alliance Atlas V rocket from Space Launch Complex 3E at the Vandenberg Space Force Base in California.
Weather still remains go, and the United Space Force has assured us that we have a green all the way through launch.
And once they go green and once this thing launches, it will be the 2000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. Has gas. Go. Electrical systems. Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operation support. Go. COM. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch.
We are go for launch.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go.
Status check. Go Atlas. Go Centaur. Go Landsat 9.
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1, engine ignition, and liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch-over maneuver. Body rates look good.
That pitch-over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges. Vehicle is now completing the pitch-over maneuver. Body rate responses continue to look good. Pump speeds and injector pressures on the RD-180 continue to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic. Vehicle passing Mach 1.
Critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50 seconds into flight, vehicle is now 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight, and vehicle has gone to closed-loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight. And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction control system on Centaur, they're prepping it.
Operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Norway's Svalbard Satellite Monitoring Ground Station acquired signals from the spacecraft about 83 minutes after launch, with the Landsat 9 performing nominally as it travelled towards its final orbital altitude of 705 kilometres. Built by Northrop Grumman, the 2,711-kilogram spacecraft is equipped with operational land imager and thermal infrared sensor instruments designed to monitor the planet in 11 spectral bands. The data gathered by Landsat 9 over the next 15 years will add to the 50 years of continuous satellite observations already obtained by the Landsat series as they monitor the growing changes to the planet caused by global warming. The first Landsat satellite was launched back in 1972. Landsat 9 will join its sister Landsat 8 spacecraft to collect data covering the Earth every 8 days. Both probes will work with other Landsat spacecraft, as well as the European series Sentinel Copernicus environmental satellites, to maintain a detailed account of the planet. United States Secretary of the Interior Deb Haaland says the data collected by Landsat 9 will provide science with information that shapes government policy on key issues, including water use, wildfire impacts, coral reef regeneration, glacier and ice shelf retreat, and tropical deforestation. This report from NASA TV.
Researchers and, well, just about anyone can download scenes from the Landsat Archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence, helping scientists and researchers understand how our planet is changing over time. It will take Landsat 9 and its sister satellite, Landsat 8 days to image all of Earth's land and coastal areas. That means we get a complete picture of Earth every 8 days. In this case, 2 satellites are better than 1. Landsats 8 and 9 can work together to provide near real-time data about what's happening on the surface of our planet. Landsat collects images of each of our planet's 7 continents. Farms, forests, waterways, glaciers, urban areas. Landsat sees it all. Remember, you can't manage what you can't measure. Whether it's deforestation in the Amazon, or ice loss in Antarctica, or urban sprawl in Shanghai.
Fire engine, liftoff. Time, 1756. We have liftoff.
Landsat 6 launched on October 5th, 1993.
Apogee kick motor should ignite right now and take Landsat to its final circular orbit.
But it never made it to orbit. NASA's team of scientists and engineers got to work immediately to figure out what went wrong. Turns out it was a rupture in the rocket fuel chamber. They used failure as an opportunity to learn. 6 years later, the team launched Landsat 7,
Liftoff of the Delta II rocket with the advanced...
one of the most technologically advanced Earth-observing satellites of its generation, still in use today. At least one Landsat satellite has been orbiting Earth since 1972. That's nearly 50 years of steadfast observation. That first Landsat proved we could gather digitally encoded data from space and changed the way we look at Earth forever. Never before seen snapshots of land resources and the environment would be key for critical decision-making decades into the future. Landsat collects light. How intense that light is tells us about what's on the ground. You can think of intensity like shades of a different color. Landsat 9, the newest satellite to join the Landsat fleet, sees 16,384 shades. That's 4 times the depth of color of the previous Landsat, meaning we'll be able to see more detail in darker spots like coastal waters and dense forests. True color images are made by combining red, blue, and green light. Combined together, these visible bands of light make up all the colors in the rainbow, and all of Landsat's true color images. Landsat also captures light that we can't see. That type of light can reveal some incredible things when you look at a false color image, like the difference between types of plants, how healthy those plants are, healthy coral reefs, and even dead coral reefs, fire tracking, ocean pollution. The possibilities are nearly endless. There are 2 instruments aboard Landsat 9. OLI-2 is all about light. Once in orbit, OLI-2 collects sunlight reflected off Earth's surface. The light passes through a set of filters to separate out 9 specific wavelength bands, in visible and infrared frequencies. Each band provides different pieces of information about what is down on the surface. The second instrument aboard Landsat 9, called TESS-2, collects thermal infrared wavelengths, or temperature signatures emitted by the Earth itself. "50 years ago, the U.S. Geological Survey had an idea. Satellites orbiting Earth that could help us monitor our natural resources. Today, the Landsat program is jointly managed by NASA and the USGS, providing an unparalleled record of Earth's changing landscapes for the benefit of all."
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Well, they say grumpy teenagers are one of the things you've just got to put up with in life if you're a parent. But a new study suggests lots of fruit and vegetables may be the key to preventing your child becoming a grumpy teen. A report in the British Medical Journal shows a survey of nearly 10,000 school students in the UK found that the more fruit and vegetable portions teens ate for breakfast and lunch, the more likely they were to have a good mental health rating. Researchers say skipping breakfast or just having an energy drink was associated with lower quality mental health, and so too was skipping lunch. Paleontologists have unearthed the fossilized remains of the earliest known ankylosaur, a typically 3-meter long, heavily armored dinosaur. The newly discovered species named Spicomelis afer lived during the Middle Jurassic about 168 million years ago in what is now Morocco's Middle Atlas Mountains. The findings, reported in the journal Nature Ecology and Evolution, consist of a rib with spiked dermal armour fused to its dorsal surface. So this herbivore had a series of spikes attached to the rib, which must have protruded above the skin, covered by a layer of something like keratin. And this is unlike any other ankylosaur known, whose armoured spikes are usually embedded in their skin and not fused to the underlying bone. Archaeologists in Israel have uncovered a vast Second Temple period quarry in Jerusalem. Because some of the stones were left in situ, the 2,000-year-old quarry is providing scientists with a golden opportunity to study the techniques used by ancient master stonemasons in order to recreate the processes by which the stones, up to several metres wide, were cut up and quarried. Large-scale building projects in ancient Jerusalem, such as the Temple Mount, required vast amounts of building materials and the ability to organise and coordinate the quarrying and transportation of thousands of stone blocks. The Second Temple was built by the Jewish people in the year 516 BCE and was destroyed by the Roman Empire in the year 70 as punishment for a series of Jewish uprisings which also saw the Romans exile the Jews from their homeland. It had replaced the original temple built by King Solomon in the year 957 BCE, which was later destroyed by the Babylonian king Nebuchadnezzar in 586 BCE after the Babylonians had conquered the Jewish people and took them into exile to Babylon. The European Commission has announced plans to force electronics manufacturers to use standardized USB-C plugs for charging all small electronic devices and cell phones. The plan will reduce waste by encouraging consumers to reuse existing chargers when buying a new device. But Apple warns that the move will hamper innovation. With the details on these stories and more, we're joined by technology editor Alex Zaharov-Reutt from ity.com.
Yeah, they want to force Apple to switch to the USB-C standard for the plug that goes into the iPhone. Currently, it's the Lightning port, and on Apple's iPads, the iPad Mini and the iPad Pros and the iPad Air, every iPad except the cheapest iPad, they're all using USB-C. The Macs switched to USB-C some years ago, but the iPhone is still Lightning. And that's because the Lightning connector was actually around before USB-C. In fact, some of the advancements that Apple made with Lightning went into USB-C.
Yeah, I remember my old iPhone 6 had a Lightning port.
Yeah, and it was reversible. It's smaller than USB-C. And Apple had the Made for iPhone program, the MFI, which was made for iPhone, iPad, iPod Touch. And that meant the cable cost more because it had a special chip inside and had to be certified by Apple to work. But it also meant the cable worked. You could buy it and be guaranteed the cable would work. There was a famous episode, I think back in 2016, where one of the first Google Pixel tablet came out with USB-C, and the programmer wrote about how they'd purchased a USB-C cable that ended up fritzing the port of that tablet and damaging it so that it was, you could no longer charge it or transfer data from it, which effectively rendered the tablet useless. And today, many of the USB-C cables, some of them are just for charging, some are for data, some of them are USB 2, some of them are USB 3 speeds. You also have Thunderbolt cables, which have the same connector as USB-C. And you've got some Thunderbolt monitors, for example, from Samsung and others, where if you plug a USB-C cable in, because it plugs in, it's the same physical cable connection type. If you plug it into a Mac or a PC and into the back of the monitor, and it's not a Thunderbolt cable, it will not send any video. It doesn't work. You've got to have the right sort of cable. So there are many different types of USB-C cable. I mean, the situation today in 2021 is much better than it was in the past, but you can still get cheap USB-C cables and more expensive ones. Look, Apple has made the transition, but Apple is saying that if they're forced to stick to one kind of cable type, it's going to stifle innovation. And look, we have had a huge renaissance in the number of cables that we no longer have to carry around. I mean, in the old days, you had the Sony Ericsson, you had the Motorola, you had a whole different stack of cables. It's sort of the same thing with a lot of the PCs that had those little barrel DC plugs, many of which have now been replaced by USB-C. It would be good if everything was USB-C, but not at the expense of companies deciding upon, creating fast charging speeds. I mean, the EU does want the ability in the USBC standard for there to be fast charging. But I think we've spoken about it on this program. There's a Xiaomi phone that can recharge to full in about 8 minutes.
Yes.
Something crazy like that, because it's using 200-watt charging. And, Apple is probably going to end up having a phone with no ports at all. They already got rid of the 3.5 millimeter headphone jack. Eventually, they already have MagSafe on the back, which is an excellent standard. 15 watts, it's not as fast as the 20-watt wired charging that Apple offers, but still, it's pretty good. And it's only going to get faster. And one less port means the phone is even more waterproof. So Apple may, thumb its nose at the EU, because the EU has said, look, if your phone has got wireless charging, you don't have to have a USB-C port. But I'm not really in favour of governments mandating things.
That's Alex Zaharov-Reut from ity.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.